Hello students, how are you all? Welcome to your own channel S2 classes. Good afternoon, good evening, good morning whenever you are watching my YouTube channel. Now in today class, last two classes we have started GOC General Organic Chemistry for the first year, and in the last two videos I have completed what it is. First, inductive effect, then hyperconjugation. Now in today class, I am going to start the most important topic is known as resonance. The most important topic is known as resonance. Resonance, very easy. Trust me, if you try to go through the topic very easily, then you will come to know each and everything regarding resonance very easy. Just see over here, you will come to know everything, don't worry. But before starting the topic, we will have to know why resonance is needed. Suppose I have taken SO4 2 minus, SO4 2 minus, and I have drawn the Lewis dot structure for this. I have drawn the Lewis dot structure. Now if you have studied chemical bonding and molecular structure, then you will not find any problem in drawing the Lewis dot structure. Still you have not studied, just understand what is the use of resonance. Suppose I have drawn the Lewis dot structure. The structure for this compound you will get S double bond O, O minus and O minus. This is the Lewis dot structure for SO4 2 minus. Now, as you already know that the bond energy of triple bond is more than double bond than single bond, and the bond length I have dictated you somewhere. The bond order is directly proportional to stability, and bond order is directly proportional to bond energy, and bond order is inversely proportional to bond length. It means more is the bond order, less is the bond length. More is the bond order, more is the bond energy. More is the bond order, more is the stability. The bond energy is this. If I am asking what is the bond length in this case, we will say opposite to bond energy, because inversely proportional. So single bond has more bond length than double bond, than triple bond. Now I will ask that suppose the bond length of this structure is, over here is X, over here is Y, over here is suppose Z, over here is suppose small p. P means Prabhat and my name is Prabhat. Oh sir. Now if I ask you that what is the bond length in this case, so what you will say, sir, Y and Z is same. Y and Z is same because both are, Y and Z is same because both have double bond. And you will say, sir, X is equals to P because both are single bond. And overall you will say, sir, X is equals to P, but X and P are equal, but it is greater than Z is equals to Y. It means over here, just understand why resonance is important. I am saying that if I am asking what is, suppose I have written over here as resonance. The resonance topic is important because if I draw the resonating structure for SO4 2 minus, suppose I am going to draw the resonating structure for SO4 2 minus. So before drawing the resonating structure, I have drawn its Lewis dot structure. And after drawing the Lewis dot structure, I have told you, sir, the bond length over here is X, over here P, over here Z, over here Y. What is the order of bond length? So you will say, sir, Y and Z have the same bond length. Whatever you know from this point, you will say directly, because bond length of triple bond is less than, triple bond has very less than double bond, then single bond has very bigger bond length. You will say double bond, these two are double bond, so Z and Y has same bond length. These two are single bond, X and P both have the same bond length. X and P equal to Z and Y, but X and P is greater than, because X and P is single bond. But actually this answer is incorrect. You are saying according to this basis, but if you see actually So you will come to know that X is equals to Y is equals to Z is equals to P. It means everywhere their bond order is same. How, sir? How it is possible? So this is because of resonance. This is because of resonance. Now understand why resonance is needed. What is resonance? I will dictate. Don't worry, sir. Just wait. Just wait for the concept to complete, but over here you will understand why resonance is important. Now, so from here you can write one point. The one structure, this part visible, everything visible everywhere, no any problem. Okay, visible. Now you can see the one structure is not enough. The one structure, the one Lewis structure, the one Lewis structure is not enough to define the property of a compound, so we need to draw its resonating structure to define its all the property properly. What I have written? What I have written, sir? What I have written, sir? पल पल कहता है दिल तुमसे होके दिल दीवाना. What you have written? I am not gonna jana. Oh, what you have telling in the Hindi, sir? I'm not saying anything. Now, what I am saying that after seeing this structure, you will come to know that according to you, X, Z and Y has the same bond length. X and P has the same bond length. X and P has same. Z and Y has same, but it is single, so it has more bond length. But overall incorrect. All the bond length is same. So this is because of the resonance. So it means one Lewis structure is not enough to define the property of a compound. One Lewis structure, because I have drawn only one Lewis structure, it is not enough to define the property of a compound. So we need to draw its resonating structure to define its all the property properly. Getting my point? And this phenomena is known as resonance. This phenomena is known as resonance. This phenomena is known as resonance. Getting what I am trying to say? I will dictate you properly. You will come to know. Can I erase this part? Okay, sir, erase it. Now this phenomena is known as resonance. Now next point, this is the first point, so that we are studying resonating structure, that is resonance. The next point is that this you will consider as the first point. The second point is that the resonating structure is the resonating structure that we are drawing with the help of resonance is hypothetical structure. What do you mean by hypothetical structure? That is not correct. We are thinking this is happens. So the resonating structure that we are drawing with the help of resonance is known as hypothetical structure, but this hypothetical structure can follow Lewis dot structure. It is not that it will disobey, it will not follow the Lewis dot structure. Again, understand, don't get confused, sir. Why we will study resonance? If you understand, then resonance became very easy. I am saying that we will study resonance because I have drawn the SO42 structure. I will SO42 minus structure. In that, you come to know that these two X, Z and Y has the same bond length. X and Y has this, P has the same bond length. X and P same but greater than Z and Y. But actually, all the bond length is same. This is because of resonance. So one Lewis structure is not capable to define the all property of a compound properly, so we are drawing the resonating structure using resonance, and this phenomena is known as resonance. The resonating structure that we are drawing with the help of resonance is known as hypothetical structure, but this hypothetical structure can follow Lewis dot structure. And now third point, with the help of resonating structure, we will draw, with the help of resonating structure, we will draw resonating hybrid structure. Resonating hybrid structure. I am denoting resonating hybrid structure as RH. So I can write short form. With the help of all the resonating structure that I am drawing right now, with that help we can draw a resonating hybrid structure, and resonating hybrid structure is not the hypothetical, is the actual structure. Resonating hybrid structure is the actual structure. Don't getting confused. Everything you will come to know whenever I started the topic. First write the theory, that is important. Now fourth point, resonating hybrid structure has low energy. Resonating hybrid structure has low energy, so it is a stable structure. So it is known as, so it is stable, not known as. It means overall you will come to know that because of the bond length checking I get confused and you are saying something different, but the answer is something different because of the resonance. It means one Lewis structure is not capable of defining all the property of a compound, so we will have to know about the resonating structure, and this phenomena is known as resonance. The structure, that resonating structure we are drawing, is the hypothetical structure. With the help of resonating structure we are drawing the hybrid structure, resonating hybrid structure, that is the actual structure, and resonating hybrid structure has low energy, so it is a stable compound. Now we are going to see what is resonance, how can we draw the resonating structure. The question arises, how can we come to know, sir, over here the resonating structure can be drawn, over here the resonating structure cannot be drawn. Now one more point I have to write, then after that I will start. Fifth point, that each compound in a structure must be planar. Each compound in a structure must be planar. Planar means, suppose I am drawing the triangle over here, so all lie on my hand, so it is a plane. It will all lie, either all lie on this axis, or all lie on this axis, or all lie on this axis. In any axis they will lie. It is not like that one is over there, one is over here, so it is not in the plane. Plane means if I am considering this, all is over here. If I am considering this, all is over here. Okay, so how can you judge it is in plane or not? So right now we will consider everything is in a plane. So regarding this topic, don't go that much seriously. You will come to know whenever you are studying aromatic compound like that. Don't worry about that. These are the all important point regarding resonance. Now I am going to erase each and every point, and then I will start where you will able to draw the resonating structure. What is the condition for the resonance? Condition for resonance. Write fast. Now again I am saying, up to that theoretical part that you have written is just for the theory part. Now when we start, actually resonance is going to be a start right now, and we will start resonance. You will not get confused. So just see over here, and trust me, this is going to be the easiest topic in your life. So now I am going to start. Condition for resonance. Condition for resonance. Condition for resonance. What is the proper condition in which we will say there is a resonance? The first criteria is that it is saying whenever you will have a pi, you know that single bond has sigma, double bond has 1 sigma 1 pi, triple bond has 1 sigma 2 pi. So whenever there is a pi, then after that sigma, then after that negative or negative. It means condition for resonance is that is that conjugation needed? Is that conjugation needed? And the conjugation is either pi sigma pi. What is the conjugation you will need? Just don't get confused, sirs. Trust me. This is the beginning of the class, and in beginning of any one of the topic, everybody, not you only, feeling discomfort that what is going on started, we are not able to understand. But trust me, after having the mid of the class, you will come to know each and everything, and you are able to draw the resonating structure by yourself. Over here, the first conjugation condition for the resonance is pi, sigma, and negative. Second condition is needed pi, sigma, and lone pair of electron. This cross, if I write, or if I write over here 2 dot, is same. 2 dot means again negative. Both are the same condition. Third, we will need if there is pi, sigma, and positive conjugation. If there is pi, sigma, negative, pi, sigma, lone pair, pi, sigma, positive. Fourth condition, we will have pi, sigma, free radical. Pi, sigma, free radical. Pi, sigma, free radical. Fifth condition, we will have pi, sigma, pi. Pi, sigma, pi. And the sixth we will have, that is lone pair, sigma, vacant, orbital. Just don't get confused. Lone pair, sigma, vacant, orbital. Something like this. Suppose we will have B, over here A, over here lone pair, over here vacant orbital. So lone pair, sigma, lone pair, it is lone pair, sigma, and vacant orbital. This is the last condition, and this is rare of the rarest condition, but I am over here to dictate you each and everything, so you are able to solve all the questions that will come. So these are the conditions in which resonance happens, and because of the resonating structure, you will come to know their bond length, everything you will come to know. Just don't get confused. I am not going to say lot of things to make you confused. So these are the conditions: pi, sigma, negative, pi, sigma, lone pair, pi, sigma, positive, pi, sigma, free radical, pi, sigma, pi, and lone pair, sigma, vacant orbital. But the thing is that they are saying if you have to say it from your mouth, don't say pi, sigma, negative. Say from the back. Negative, sigma, pi. Way of saying. No need to say. If anybody is asking what are the conjugation structure, you can say pi, sigma, pi. Pi, sigma, negative. Pi, sigma, lone pair. Pi, sigma, positive. Pi, sigma, free radical. Pi, sigma, pi. You can say. But best way to read this is negative, sigma, pi. Lone pair, sigma, pi. Positive, sigma, pi. Free radical, sigma, pi. Pi, sigma, pi. Over here, I have written from the back. Lone pair, sigma, vacant orbital. Lone pair, sigma, vacant orbital. Getting? Now we are going to see this part I am erasing. Now I am going to show you that similar structure that I have written over there, SO4 2 minus. Then I will go line by line. First, I will dictate you that structure. Suppose we will have S double bond O, the single bond O minus, single bond O minus, double bond O. This is the structure of SO4 2 minus. Now if you see this side, so you will say, sir, pi, sigma, negative. Conjugative. Conjugation means kramsa, means lagatar, means line by line. It is not the gap. It is not like that. Suppose pi, sigma, 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 then lone pair. So pi, sigma, sigma, then lone pair. No. It is not correct. Conjugation means continuous. Pi, sigma, negative. So if you see this side, there is a pi, sigma, negative, means lone pair. Or negative you can say. In this side if you see pi, sigma, negative. This side if you see pi, sigma, this negative is either upper or lower. It is negative. Pi, sigma, negative. It means either you can go from here to here, it is doing conjugation, resonance possibility, or you can go from here to here, it is doing resonance, or you can go from here to here, it is doing resonance, or you can go from here to here, it is doing resonance. So I will do line by line. Suppose if I started from this first part, in the first part I am going to do, so we will have double bond O minus, over here O minus, and over here double bond O. What happens that this lone pair of electron comes over here. So because of that, the sulfur get more bond. So this bond coming over here. It means in this case, what happens? First lone pair of electron converted to bond pair. First lone pair of electron converted to bond pair. Because of that, the bond pair of electron converted to lone pair. So what you will get? You will get the first structure something like this. Over here S, this will become O minus. Over here it will become double bond. Over here O minus. Over here double bond O. Now if I go with the second one, so what happens? Pi sigma negative. Now this lone pair come over here. So this double bond goes either this side or this side. Don't get confused, sir. You are doing from this side, taking from that side. No any problem. Coming over here. So what you will get a structure? S O minus double bond O. Now over here double bond O and this became single bond. Now over here again lone pair is converted into bond pair and bond pair is converted into lone pair. So likewise, if you draw the structure from this side, this side, this side and this side, what you will come to know? Sometimes the double bond comes over here, sometimes over here, sometimes over here, sometimes over here. It means double bond is fluctuating to all of the structure time to time to time to time. And minus sign is on two structure, they will come over here also. Getting it? Means if you draw it, if you are not able to understand this part, no need to worry. I will go line by line because I have given this question first, so I am dictating this. After that you will, if I go line by line, you are able to understand. Don't worry sir, please. Now after seeing all these things, these are the resonating structure. This structure that I am drawing is the resonating structure. Now I am going to draw resonating hybrid structure. So what you will say, sir, in the hybrid structure there is S, single bond O, single bond O, single bond O, single bond O, and sometimes double bond comes over here. So I have written dot dot dot, it means partial double bond. Sometimes double bond comes over here, sometimes double bond comes over here, and sometimes double bond comes over here. It means this is the original structure. Now one has minus, this has minus, 2 minus is distributed on 4 oxygen. It means minus 1 by 2, minus 1 by 2, minus 1 by 2, minus 1 by 2. Again over here 1 minus. Over here, overall structure has how many minus? 2 minus. It means 2 minus is on the oxygen, 2 minus is on 2 oxygen, but now that minus is distributed on 4 oxygen and 2 oxygen have already 1 minus. It means it is going to be distributed half over here, half over here. From this oxygen half over here, half over here. Now this is the original structure after doing the, this is the hybrid structure or after doing the resonating structure. Now if I say this is X, this is Y, this is Z and this is P, so charge is also same. Everywhere there is a partial double bond. So if I ask what is the bond length priority, you will say, sir, X is equals to Y equals to Z is equals to P. Getting it little bit. Right fast, right. Don't worry. This conjugation condition, right? I will dictate each and every part properly. This is the first time for you, I understand, and you will believe me, you will come to know very properly. Written? Now suppose I am going to take another example. Right fast, I am erasing this conjugation condition. Line by line, I will dictate you the each and everything. Don't worry. And trust me, this is very easy. Once you go with that, you will come to know very easily. Up to now, suppose, one more example I am taking. And hybrid structure, that is the original structure. The hybrid structure is original structure. That is actual, not original, actual structure. Now, suppose I have taken O31 minus. O31 minus. Now what is the structure? O double bond, O single bond, O minus. Now, if I am saying the bond length over here is X and over here is Y, I am asking what is the bond length. So you will say X greater than Y and you will become wrong. What you will say? How wrong, sir? You will say over here pi sigma negative. So it will do resonance. What it will do in the resonance? O double bond O, the negative charge, this negative come over here. It means bond pair is lone pair is converted into bond pair. Because of that, this bond comes over here, because oxygen needs only 3 bond max to max. It is going to be 4. That is not correct for oxygen. So now bond pair converted into lone pair. So you will get the resonating structure over here is O, the double bond come over here, O single bond, O minus. So if you draw the hybrid structure, resonating hybrid structure, if you draw, so what you will say? O over here single bond, over here single bond, over here O, over here O. There is a partial double bond, there is a partial double bond. 1 minus on 1 oxygen, 2 oxygen is taking the minus. It means it has minus 1 by 2 charge. It has minus 1 by 2 charge. This is our hybrid structure. Now this is X, this is Y. The bond length is same. X is equals to Y because charge is also same and the partial double bond is also same. Suppose I have taken another structure CO3 2 minus. If you draw the structure over here, what you will get? C double bond O, single bond O, single bond O negative or O negative. Now one question they will ask कि how many total number of resonating structure. The total number of resonating structure, in that this is the original structure of ozone and this is the original resonating structure. We will say total number of resonating structure is 2. Original structure, because O31 minus has this structure. Now you are doing resonance, you will get this. So these two are considered to be the resonating structure. Because of these two, we are able to draw the hybrid structure. The total number of resonating structure is 2. Suppose I am drawing there, so what you will say? Sir, in this case, we will have the conjugation of pi sigma negative. So either this will do, so what you will get? O minus single bond. Over here, this lone pair come over here. It means lone pair is converted to bond pair. Because of that, this bond will goes over here. It means bond pair is converted to lone pair. This two condition happens. This became double bond O. This became single bond negative. Another path that, and whenever you are drawing the resonating structure, give the arrow like this, both the side. Another thing that you will do, pi, sigma and negative. In this lone pair come over here. So you will get O double bond C over here O minus. If it is doing, it is not doing. If it is doing, it is not doing. And over here you will get single bond. This oxygen is going this side, so you will get O minus. So if anybody is asking total number of resonating structure, so what you will say, sir? 1 original structure, this one 2, this one 3. It means total number of resonating structure is 3. If someone is showing to draw the hybrid structure, resonating hybrid structure for this compound, so what you will say? Sir, the resonating hybrid structure is something like this. C over here single bond O, over here single bond O, over here single bond O, and there is partial double bond over here also, partial double bond over here also, partial double bond over here also, and now 2 oxygen has a charge minus minus, 2 minus, 1 oxygen is charge taking. To charge you will get mathematics student, you will come to know minus 2 by 3. It also has minus 2 by 3. It also has minus 2 by 3. If you add all the 3, you will get what? Minus 2, minus 2, minus 2. You will get minus 6 by 3. Cutting became minus 2. So now if I am writing over here X, over here Y, over here Z, so we will say bond length of X is equals to Y is equals to Z. Now I think you are able to understand that how can you find the total number of resonating structure and total number of resonating structure, what is the hybrid resonating structure, how charge I am distributing over here and over here. Now we will go line by line, right? Fast. Now we will go line by line, pi sigma negative, then pi sigma lone pair, then pi sigma positive. Likewise, we are doing the resonating structure line by line. Just come over here. Can I erase this? And in resonance, in today class, I will complete how to draw the resonating structure and hybrid structure. And in tomorrow class, I will go with the stability of resonating structure. What I will dictate? The stability of resonating structure. Because if I try to complete resonance as well as the stability of resonating structure, both will become too much long video. This video I will complete what is resonance, total resonating structure, and in second video I will complete stability of resonating structure. Then I will start mesomeric effect. The first condition for the resonance, we will have pi sigma negative. It means the structure should be something like that: X double bond Y single bond Z, and this Z has negative. So we will get pi sigma and negative over here. Sir, give me the original structure. Don't draw with XYZ. Okay. Take. If I am taking CH2 double bond CH single bond 1 2 3 4 single bond CH2 minus. This is the original structure. Now what happens? This negative charge comes over here. It means first lone pair converted to bond pair, then this charge comes over here, then bond pair converted to lone pair. The structure you will get, X became negative, the resonating structure. This became single bond Y, this became double bond Z. Now how many total resonating structure, how many you will get? Sir, two. One is this original, and this two resonating structure. Their resonating hybrid structure is what, sir? So X, Y, Z, over here single bond, over here single bond. There is also a partial double bond. There is also a partial double bond. Charge over here 1 minus 2 is taking. So minus 1 by 2. Minus 1 by 2. Same thing you will do over here. One is the structure. This lone pair coming over here, the lone pair converted to bond pair, and this coming over here, the bond pair converted to lone pair. So we will get the resonating structure CH2 over here minus single bond CH double bond CH2. The total number of resonating structure is how much? 1 and 2. Now what is the resonating hybrid structure? We will say, sir, CH2 single bond CH single bond CH2. Over here there is a partial double bond. Over here there is a partial double bond. It is taking the electron from 1 minus to minus 1 by 2. Minus 1 by 2. The first condition criteria satisfied. Now if it is X, if it is Y, the bond length is same. Bond length, bond energy, everything, bond energy, bond length, bond order, everything is same. Getting? Because it also has two bond like that. Getting my point? Right fast. First condition complete. Now we will go with the second condition, that is pi sigma lone pair. Right fast, written, sir. Now resonance getting how I am trying to dictate. Yes, sir. Little bit getting, not 100%. If not getting 100%, try to see this again. Trust me, this is very easy. I think. Now what you think, I didn't know. So I also think. Second one, we will have pi sigma lone pair. Now in that pi sigma lone pair, first I am taking X condition. So X double bond Y single bond Z has a lone pair. Or you can take CH2 double bond CH single bond NH2, and this N has a lone pair. It is good to take like this. Now from here what happens? This lone pair converted to bond pair, lone pair converted into bond pair. Now this bond pair converted into lone pair. So what happens? X, resonating structure X, negative, not negative, lone pair. Now lone pair. Now single bond Y, double bond Z. If I am asking total number of resonating structure, the 1 and 2 is, sir. And if I am asking what is the resonating hybrid structure, we will say, sir, X, Y, Z, single bond. There is a partial double bond. There is a partial double bond. Lone pair over here also. Lone pair over here also. So lone pair is also known as negative. Both have the same meaning. Both have the same meaning. So over here you will write minus 1 by 2. Over here you will write minus 1 by 2. Getting? Or if you don't want to write minus 1 by 2, then you will write over here 1 dot, or you will write over here 1 dot, because both side it is going. Getting my point? In this way you can write. In this case, what happens? This lone pair coming to bond pair, the lone pair converted to bond pair. Now this bond pair converted to lone pair. So because of that, the resonating structure, what you will get? Don't give the arrow like this, you will get an arrow like this. So you will get CH2. Over here there is a lone pair, single bond CH, double bond NH2. If I am saying draw the resonating hybrid structure, so what you will say? CH2, single bond CH, single bond NH2. Over here there is a partial double bond, there is a partial double bond. It will get minus 1 by 2, it will get minus 1 by 2, or it will get one lone pair, or it will get one lone pair because one electron because two electron is converted into lone pair. Getting my point or not getting it? Yes sir, getting little bit. Now total number of resonating structure, so you will say sir 1 and 2. This 2 is the total number of resonating structure. Resonating hybrid structure is not considered to be the resonating structure. It is the actual structure. So we have completed the second condition. Now we are going with the third condition. I will take some complicated question also, don't worry. Now we are going with the third question. Now can I erase it? Okay sir, erase it. Now third condition, two condition we have satisfied. Now third condition we will have, that is third condition we will have, if we will have pi sigma positive, so I am taking X double bond Y single bond Z positive over here. So what happens? This pi bond shifted over here. So because of that, positive sign comes over here. Directly not come, because this pi has 2 electron, and this 2 electron is going over here because it will get the deficient of electron, so X will get positive. So from here the resonating structure, what you will get? First you will say that bond pair is only converted to bond pair. In this, no lone pair conversion. Bond pair is converted to bond pair, and you will get X, single bond Y, double bond Z, and positive sign come over here. So if I am asking total number of resonating structure, so 1 and 1, 2. Sir, resonating hybrid structure, you will say sir X, single bond Y, single bond Z. Over here there is a partial double bond. One positive is converted into 2, so plus 1 by 2, plus 1 by 2. Getting my point? 100%. Now if I am saying in this case, sir, take the proper example. So CH3 single double bond, not CH3, CH2 double bond CH single bond CH2 plus. Now same thing happens. The bond pair is converted to bond pair, because bond pair electron is converted to bond pair electron. So you will get CH2 single bond CH double bond CH2. Over here you will get plus. So if anybody is asking total number of resonating structure, so you will say 1, 1 and 2. Resonating hybrid structure, so you will say sir CH2 single bond CH single bond CH2. Over here there is a partial double bond, over here there is a partial double bond, over here plus 1 by 2, over here plus 1 by 2. Getting? If asking bond length, bond order, you will say same. So whenever resonating structure is possible, then the bond length, bond order is going to be same. Completed. Now come to the fourth part. तुझे भूल अंते अमला परू अंते अंधा पल्लू. No Pallu, sir, you are singing a wrong song. You didn't know the meaning of this song. Yes, sir, I didn't know, but I'm trying my level best. Oh, sorry. Okay, come to the fourth part. First we have completed pi sigma negative, pi sigma lone pair, pi sigma positive. Now we are going to see pi sigma free radical. So X double bond Y single bond Z, there is a dot. Now in this case, if you have to draw the resonating structure, what happens? You will get over here like this, and this will give one electron. Over here one dot, over here one dot. So you will get X dot. Because one dot is already there, this dot became. So over here you will say that bond pair is converted into free radical. Bond pair is converted into free radical. So you will get over here single bond Y and this dot dot became double bond Z. The total number of resonating structure is how many? 2. What is the resonating hybrid structure? What is the resonating hybrid structure? You will say, sir, X, single bond Y, single bond Z. There is a partial double bond. There is a partial double bond. One dot is converted into 2. One dot is converted into 2. So what you will get? Dot by 2 and dot by 2. Yani half dot. Half dot and half dot ka bhi dot means the half of the dot. Charge is not that much important, but still I am dictating. Sir, take me the proper example. CH2 double bond CH single bond CH2 dot. So over here what you will do? This will break like this. This is called homolytic fission. This is called homolytic fission. Bond pair is converted into electron and that electron is known as free radical, not lone pair. Lone pair means 2 electron. So over here what happens? You will get the resonating structure for this compound is CH2 dot single bond CH double bond CH2 because this dot and this dot became double bond. Now total number of resonating structure is how many? You will say, sir, total number of resonating structure is 2. Resonating hybrid structure is what, sir? So CH2 single bond CH single bond CH2, it is going to be converted into partial double bond. Charge is 1 by 2 dot 1 by 2 dot dot, the half of the dots. Getting my point? So this is the fourth point. Now come to the fifth one. Right fast. Now I'm coming to the fifth one. Fifth one is pi sigma pi. Pi sigma pi. Pi sigma pi. Pi sigma pi. Now I'm going to convert the fifth one, that is known as pi sigma pi. So X double bond Y single bond Z double bond P. So you will see pi sigma pi conjugation. So what happens? First, this pi bond come over here. It means bond pair is converted into bond pair. Then this bond comes over here. It means bond pair is converted into lone pair. So how many number of resonating structure you will get? You will say X became single bond Y, over here became double bond Z, over here became single bond P, and over here negative charge. So if I am asking what is the total number of resonating structure, what is the total? Now it can do again resonance. Pi sigma lone pair became. Then again what happens? But these two are the total number of resonating structure. Okay, just write. I am filling little bit ink. Just write fast. Now over here, now the total number of resonating structure is how many? Oh, filled the ink still. Okay. Total number of resonating structure you will get 2. Now as this bond has given its electron, so it will get positive. Getting? This bond is going, na? Previously we have done positive. So this is the resonating structure. Suppose you are asking, sir, give me the proper structure. So I am writing CH2 double bond CH single bond CH double bond O. Now over here if you see pi sigma pi, so what happens? This bond pair is converted into not lone pair. This bond pair is converted into bond pair. The bond pair is converted into bond pair. Second, the bond pair is converted into lone pair. The first, you will get over here the resonating structure is CH2 single bond CH double bond CH single bond O, over here minus because taking the electron, over here plus because giving the electron. If anybody is asking draw the resonating hybrid structure, you will write X single bond Y single bond Z single bond P. First, there is a double bond. Okay, sir, there is a double bond. Second, there is a possibility of double bond. Yes, sir, there is a possibility. Third, there is a possibility of double bond. Yes, sir. In the first structure, no charge. In the second structure, there is a positive charge and there is a negative charge. So this is the resonating hybrid structure. Total number of resonating structure is 112. Resonating hybrid structure, so CH2 single bond CH single bond CH single bond O, partial double bond in the first case, double bond of double bond. In the second case, over here there is a possibility of double bond. First case, over here there is a possibility of double bond, and in this there is a negative, and in this there is a positive. So this is the resonating hybrid structure, and in every cases the resonating hybrid structure is the stable structure, is the original actual structure, but the resonating structure is the hypothetical structure. Now we will have the last case written. Easy na? Sir, please. Tell. Yes, sir. Easy. Not tough? No, sir. Now the last case we will have, then I will, after completing the last case, we will do some question, 2 to 3 questions we will do to understand more about resonating structure. Last case we will have what? 6th number, lone pair sigma vacant. In that, suppose I have taken X, Y, over here there is a lone pair, over here there is a vacant. So what happens? This lone pair is converted into bond pair. So you will get X double bond Y. Similarly, if I have taken over here CH2 plus single bond OH. O has a lone pair, it will give the electron over here. So you will get CH2 double bond OH. How many resonating structure? Total number of resonating structure is 2, this and this. In this case, total number of resonating structure is 2. Now if you are asking resonating hybrid structure, so what you will say? X, over here we will have single bond Y. Now in this case there is a partial double bond. Over here there is a lone pair, and over here there is a vacant orbital. In this case, CH2 single bond OH. There is a partial double bond. This is the resonating hybrid structure. There is a positive and there is a presence of lone pair. Getting my point? So these are the things that in which we are drawing the resonance things. And we have completed resonance. Now the next topic we will start is stability of resonating structure. But I don't want to stop the video over here. I just want to draw some more resonating structure, some random resonating structure, some random resonating structure I will take and draw it over here. Suppose I have taken over here, very good example, first one, that is benzene ring. Suppose I have taken over here benzene ring, and I'm asking, draw the resonating structure, hybrid structure, and tell me how many number of resonating structure is there. So what happens? First you will say, sir, there is a first conjugation is there or not? Yes, sir. Pi, sigma, pi, sigma, pi, sigma. Everywhere there is a conjugation. So this is the first structure. First structure is also considered to be the resonating structure. Second, this pi bond comes over here. So what happens? You will get over here the benzene ring. This double bond I have not touched. This I have not touched. This come over here, it means it will become lone pair, and coming from this carbon, it will get positive. Now in the second case, what happens? This lone pair is try to come over here as a bond, still conjugation, pi sigma lone pair sigma positive, positive sigma pi, conjugation is there. So this will come as a bond, so this will come as a lone pair. Getting my point? So as it will comes as a lone pair from here, what you will get the resonating structure? You will get the resonating structure something like this. Over here there is a double bond. This will come over here, and as it is coming over here, you will get negative over here, and as it is going from this position, so you will get positive over here. Getting my point or not? Does I have written wrong over here somewhere? This bond coming over here, you will get negative on this side, it will get positive. Okay, now this coming over here, you will get okay, correct. Now come to the next case. No, not coming positive over here. Sorry. Positive to sorry. Understand what happens? This is benzene ring, first structure. Now pi sigma pi is the resonating structure. First this bond pair come, so it will get positive, and it will get negative, positive. Now this negative comes as a bond, so this will goes over here negative. Now this is coming, this is not breaking the bond, and it is breaking the bond, so it is satisfying, so no positive is over here only. Now what happens? it will come over here as a bond, it will goes over here as a lone pair. So what you will get? Ringa, 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 ringa. Over here you will get over here negative, and this will become bond. This is bond, the positive over here. Now what happens? This lone pair comes this side. So the positive sign gone, and the double bond comes over here, over here, over here. So this is the first, second, third, fourth, fifth. So if I'm asking what is the total number of resonating structure, we will say 5. If I'm asking draw the resonating hybrid structure, so we will draw the double bond over here. Sorry, benzene मतलब cyclic structure, and you will say कि sir double bond is over here, in this over here also, sir over here also, see over here also, sir over here also, sir over here also, sir over here also, and everywhere there is a double bond. The positive charge over here, the negative charge, sir, in this position, the negative charge in this position, the negative charge in this position, and this is known as the hybrid structure. So whenever we are drawing the benzene ring, we will draw the structure likely this, because this bond is moving. Now again I am going to do some more question to make you more understanding. Write fast. Written, sir? Okay. Come with the some more question. Suppose I have taken the structure something like this benzene ring. Suppose over here, and I am writing over here OH. Now you will say कि sir O has a lone pair. So you will say sir conjugation is there. Pi sigma lone pair, or pi sigma pi sigma pi sigma pi. Inside conjugation, outside conjugation, first structure. This lone pair of electron coming over here. Because of that, carbon became 5 bond. 1, 2, 3, 4 already. It is coming, became 5 bond. It is going like this. The first resonating structure you will get something like this. Over here there is a double bond OH. Because oxygen has given its lone pair the positive sign, and this lone pair come over here. This double bond not touched, not touched. Now this will come over here. This is going over here. What you will get? Ringa, 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 ringa. Over here there is a lone pair, because this is coming. This is coming over here, double bond, double bond. This is not touched, double bond, OH, positive is there. Now this lone pair is coming over here, so this is going over there. So what you will get? Ringa, 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 ringa. Double bond over here, double bond over here, and the lone pair over here, and the double bond O over here, H over here, negative sign, positive sign. Now this lone pair comes over here, the oxygen is taking its own electron. So you will get again benzene ring, but double bond over here, and over here, single bond OH. Now if I am asking what is the first, second, third, fourth, fifth, if I am asking what is the total number of resonating structures, or you will say 5. Draw the resonating hybrid structure. You will say sir benzene ring I am drawing. Okay sir, draw it. Now in the benzene ring everywhere there is a double bond. So ringa, 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 ringa. Now over here there is a single bond, but oxygen also getting double bond. Partial OH. Oxygen also has double bond. Now in this case oxygen has positive also. Now lone pair come over here. Lone pair come over here. Lone pair comes over here. So this is the hybrid structure. Getting. Now one IIT JEE advanced question. Understanding, sir, seriously tell me, I am trying my best to make you understand the resonating structure. For the first year, this is the first time you are studying resonating structure. For the second year, you have already studied a lot of time. Now can I erase it? Okay sir, erase it. Now I am going to draw one resonating structure that has been asked in IIT JEE Advance. It is asking, the question they have asked that total number of resonating structure and IIT Advance. But bro, it is easy. They are giving like this: the benzene ring, over here double bond. Then again one ring they are giving. Then over here, and in this place they are giving O minus. And now they are asking what is the total number of resonating structure you can draw with this IIT JEE Advance. Now what you will do? See over here properly. One shot, see it. This will come over here, double bond. So this will goes over here. Okay, sir. Getting it? Now conjugation is there. Pi sigma pi, or you will go pi sigma pi. Then from here pi sigma pi pi. This double bond this side or this side, both have the same meaning, na? Not getting confused. This side if I am writing double bond, or this side I am writing, both are the same, na? Only one bond, na? So this side or this side same. So first, this is the first structure. This is coming over here, this is going over there. So what you will do is, sir, second structure, there is no any touching of the double bond over here. There is the benzene ring again. This will become double bond O minus became plus because giving the electron. And over here you will get lone pair electron. Is there any problem? This double bond as it is. Now this double bond comes on this position. So this double bond going over here. Getting? There is only one possibility. So what happens? We will get ringa. Over here double bond. This ring, ringa. Over here there is a double bond O plus. Now this comes as a bond. This bond so as it is. Now you will get lone pair over here. Now you have the two paths to go. One path that you will give the lone pair over here. So this is going over here. The first path if you follow, you will draw the structure something like this. Just understand. So you will draw ringa. There is a ring over here. Then ringa, double bond O plus. Now this is coming over here, the double bond coming over here. This is going over here. This will come like this. Now this lone pair coming over here, oxygen is taking the electron. So you will get the resonating structure again. This over here. This double bond. Now it is coming over here as a double bond, and over here you will get single bond O minus. So up to now, how many you will get? 1, 2, 3, 4, 5. But some possibility that in this case, instead of going that side, it will also comes this side. Na? All the possible conjugation, pi, sigma, lone pair. So it will come this side. So if it will come this side, all the side you will have to check. So what you will get? This. So now, if it will come this side, so this bond goes that side because carbon valence is not satisfied. Come over here. Now this is coming over here, became double bond. And now this. Already this double bond not touched. This has to touch for this, na? And this has double bond O plus. This double bond has not touched this and this. This lone pair has come this side. Now this lone pair is coming this side. This is going as a lone pair. So what you will get the another structure? This. Over here bond. Over here lone pair. This bond is as it is. Now this. Over here this double bond not touched. This double bond not touched. Double bond O plus. Now this will come over here. So this is going as a lone pair. Getting my point? So what you will get the another structure? Ringa. This not touched. This is coming as a bond, the double bond. So over here ringa. This has not been touched. Double bond O plus, and this is coming as lone pair. Now this lone pair comes as a bond pair. So this oxygen is taking the electron. So what you will get the structure? this as it is, as it is, as it is, this over here bond, over here bond, becoming single bond, negative. Now up to that you have completed 5, 6, 7, 8, 9. The total number of resonating structure is 9, and you have qualified IIT JEE Advanced. If you have understand, very good. Not understand, see it properly. If anybody is asking, draw the hybrid structure, you will say, sir, this is the structure. Now over here there is a single bond O. Now there is a partial double bond, and in this you are getting positive. Now the ring, this ring is moving the electron everywhere, no any problem. In this ring, first double bond on this position, over here come, over here come, yes, come over here. This position come, this position, yes sir, come. This position already, this position come, yes. The ring is also moving in this like that. Where you will get the negative? First you will get negative over here, then you will get the negative over here, then you will get the negative over here, then you will get the negative over here. The positive and negative you will get. So original structure negative, lone pair giving, so there is a positive charge you have to take. Now over here they are giving over here they are getting, then over here they are getting, or any possibility no. So these are the resonating structure, but they are not asking the resonating hybrid structure. They are not asking the resonating hybrid structure. They are just asking how many total number of resonating structure is there. Now from my side, I have tried my level best to make you understand what is resonance. Now in tomorrow class, I will dictate you how to find the stability of resonating structure. It means which resonating structure is more stable, which resonating structure is less stable. That is the most easiest topic. This is also easy. So now I think that you have understand all the things that I am trying to dictate, and the time come up to, this is the first time when the time come up to 1 hour 1 minute 46 second. It means totally exactly 1 hour. And don't worry about the hybrid structure. No one will think, sir, over here there is a minus, now you are giving plus. So this minus comes and became plus everywhere. It means the plus charge comes over here, that minus distributing. This is the hybrid, correct? Don't worry. Okay. Now if you didn't understand, you can ask me on the comment box. I will not dictate the theory. I will dictate you some more questions. On that basis you will come to know. So bye. Have a nice day. Enjoy. Take care and try to study hard, so you will be get good marks in your life. And I am also trying my hard to give you the good marks to complete the syllabus. Bye. Thank you. Okay.